Hey there, Mr. Sutton here, bringing you the Algebra 2 4-2 Part 3 homework solutions on perfect square shortcuts and Pascal's triangle. For this first problem, since we have basically the same numbers with opposite signs, conjugates as it were, this is one of those a plus b, a minus b situations, so we're going to use the shortcut formula a squared minus b squared, which basically just means we're going to square both the terms in these parentheses and stick a minus between them. So 2y, if I square that, I'm going to get 4y squared. 5 squared is 25, so this is 4y squared minus 25. For this problem, since I have a squared binomial, I can use the a squared plus 2ab plus b squared shortcut here. So I'm going to square the first thing, which is just going to give me m squared. I'm going to multiply the two things together and double it for that 2ab. M times 6 is 6m, and then doubling that gives me a plus 12m. And then I square the last thing to get b squared, so that's going to be 36. On this problem, I have a squared binomial, so I'm going to use a squared plus 2ab plus b squared. So my a in this one is 3c. If I square that to get a squared, that's going to be 9c squared. To get 2ab, I have to do 2 times 3c times negative 5. So that's 6c times negative 5 is going to be negative 30c. And then finally, to get b squared, I have to do negative 5 squared, which is a plus 25. On this problem, I have a binomial to the third power. So since this is higher than second power, I'm going to use Pascal's triangle to write a shortcut formula, and then I'm going to apply it. So we've got the top level of the triangle, that's 1, and then 1 and 1, there's row 1. Row 2, we've got 1, and then 1 plus 1 is 2, and then we have another 1. And then we have a 1, 3, because of 1 plus 2, another 3, and a 1. So this is our third row of Pascal's triangle. This gives us our coefficients of our shortcut formula. So this one is really 1, a to the third, b to the 0, which I don't have to write b to the 0. This 3 now is going to be a plus 3, a to the second, b to the first. Then we have a plus 3, a to the first, b to the second. And finally, this one is just 1, a to the 0, which we don't really care about, b to the third. So in this context, a is this 4n, and b is the negative 3. So I have 4n cubed, and then we have 3 times 4n squared times negative 3. Next, we have 3 times 4n times negative 3 squared. And then finally, b cubed is negative 3 cubed. Going through and simplifying a little bit more, 4n cubed, that's going to be 64n to the third. And then for this next one, I need to apply the exponent before I multiply anything. 4n squared is 16. And let's see here, it's 16n squared. 3 times negative 3 is negative 9, so we have negative 9 times 16n squared, which I believe is negative 144n squared. Yep. And then for this next one, let's square the negative 3 first. That's going to be a 9. And then we've got, let's see here, 9 times 3 is 27. 27 times 4 is 108, and we have an n along there as well. And then negative 3 cubed is going to be negative 27. And there we are. For this problem, since I have a binomial being raised to something higher than the second power, this is fourth power, I'm going to use Pascal's triangle to figure out a shortcut formula and then use it. So we've got my first level of Pascal's. This is row 0. Here's row 1. For row 2, we've got 1, 2, 1. Remember, we're just adding the numbers above a number and writing 1s on the outside. Next, we've got 1, 3, 3, and 1. And then finally for row 4, I've got a 1, and then 1 plus 3 is 4, 3 plus 3 is 6, and then we have another 4 and a 1. So this gives me the coefficients of my AB shortcut formula. This one is 1a to the fourth power, because it's the highest power you can get, and then b to the 0, which we don't care about. Then we have 4, a to the third, b to the 1. So a goes down by an exponent, b goes up by 1 for every step to the right here. Next we have 6, a squared, b squared, and then this 4 is a to the first, b to the third, and then we have 1b to the fourth. In this problem, this np term is actually my a value, so that's going to be interesting. And then negative 1 is my b value. So we've got np raised to the fourth. Next we have 4 times np cubed times negative 1. Then we have 6 times np squared times negative 1 squared. Then we have 4 times np to the first and then negative 1 cubed. And finally this is going to be negative 1 to the fourth power. All right, let's carefully evaluate each of these to simplify it. So if we have multiple things being multiplied in here with an exponent, everything gets the exponent. So we have an n to the fourth and a p to the fourth. For this next one, we have 4 times negative 1, which is negative 4. And then that's an n cubed p cubed to go along with that. For this next one, negative 1 squared is just 1, so we don't have to worry about it. So we have 6 n squared p squared. For the next one, negative 1 cubed is negative 1 times 4 is negative 4. So this is negative 4 np, kind of like the second term but with a different exponent. And then finally this negative 1 to the fourth is positive 1, so that's just a plus 1 there. On this problem, I'm doing g plus 2 to the fifth. Since this is higher than second power, I am definitely using Pascal's triangle. I don't want to write 5 of these out and multiply them together. That's just a mess. So here is row 0 of Pascal's, and row 1 and row 2, we've got 1, 2, and 1. Row 3, we've got 1, 3, 3, and 1. For row 4, we've got 1, 4, 6, 4, and 1. And then row 5, just using this pattern of writing ones and adding the two things above the number to get all the middle numbers. We've got a 1, we've got 5, 4 plus 6 is 10, 6 plus 4 is 10, 4 plus 1 is 5, and we have a 1. So 1, 5, 10, 10, 5, 1. These are the coefficients in this fifth row for my shortcut formula with the a's and the b's. So this 1 is 1a to the fifth, b to the 0. This 5 is 5a to the fourth, b to the first. Then we have 10 a cubed b squared, and then 10 a squared b cubed. 5a to the first, b to the fourth, and then 1b to the fifth. So for the a's and the b's, g is my a value, and 2 is the b value here. So a to the fifth is really just g to the fifth. Then we have 5g to the fourth times 2. And then we have 10g cubed times 2 squared. And 10g squared times 2 cubed. Then 5 times g times 2 to the fourth. And finally, this last one is 2 to the fifth. So that's g to the fifth, nothing to really do there. 5 times 2 is 10g to the fourth. Next up, 2 squared is 4 times 10 is 40, so this is 40g cubed. And 2 cubed is 8 times 10 is 80, so 80g squared. 2 to the fourth is 16 times 5 is 80, so this is plus an 80g. And then finally 2 to the fifth is plus a 32.